Hey there, Ed from Barnabas again. We are here working on the second coding video for the Wi-Fi Wheeler. Alright, so before we get started today, I'm going to tell you about what we're going to cover in this video. We're going to do some whiteboarding and then doing some coding as well. So just as a recap, the first video I went over the code and kind of made a few changes. Didn't go too deep into it, but talked a little bit about the high level stuff. So today we'll go a little bit deeper. I want to cover pins, what the role of pins are on this WeMos board here that you see in this middle right there screen, and also while loops. So again, this series of videos, I want to make it approachable for anyone who wants to do the project. So if some of this stuff seems like review for you, feel free to skip it, but I do want to create a good set of videos for anyone. So that's why I want to start with pins and also loops. Okay, all right, so let's get started. Here's the whiteboard. Let's talk about the WeMos board. So the WeMos board is the computer of our Wi-Fi Wheeler. It's this blue board here. So I'm going to write WeMos. Okay, and then draw a little box. I'm going to be drawing a wiring diagram. You also can call it a system level diagram here. So we have the WeMos board, and we have a bunch of pins on it. So let's change my screen here. Okay, so if you look at the white writing here, okay, where my finger is going up and down here, it starts. You'll see white writing says RX, TX, D0, D1, and so forth. And then next to it, you're going to have some pins. These are called pin headers with these holes in them where you can stick pins to connect to these different pins. All right. So I want to bring your attention to D4. All right. You might not be able to see it clearly, but if you look at your board, you're going to see D4 around this area where my finger is tapping. All right. So let's go back. Say D4. Okay. So what is a pin? So you're going to hear that a lot. Pins are very important. Pins allow the computer board, which is the WeMos, to interact with the outside world. Now, there's two modes for pins. Pins can either be an input. For an input, it means it's sensing or something's going into the WeMos. For example, if you're going to connect a button or some other kind of sensor, like a sound sensor, or what else is there's a bunch of different sensors. Distance sensors, sensing how far something is. So if the WeMos computer is receiving something, then it can be set as an input. Okay, I like to think of it like the five senses for humans. Okay, like sight is one of them, smell is one of those senses. Whenever we're talking about those senses, we're receiving information inward, right? We're not necessarily sending out things. Like, for example, if I'm making a sound like I'm talking right now, I'm sending stuff out into the world. That's going to be an output, not an input. So on that note, the pin can also be an output. Okay, so if you want to connect a light or a motor, something like that, where you're sending motion or sound or anything out, you want to set the pin as an output. Okay, so looking at D4, we can see that D4 is a pin and it connects to the outside world. So I'll just draw a line here and say, well, what are we going to connect to? Okay, well, D4 on the WeMos is a special pin, and it is actually already connected to a light that's on the board. Okay, and we saw it blink in the first video, but I want to go a little bit deeper today, right, to explain that. So on the WeMos board, you're going to have a light, and here's a symbol for an LED in electronics. All right, this little triangle with this line represents a diode. Okay, I might as well just go deep, right? This is hopefully interesting to you all. I have a background in electronics, so I like going deep on this stuff. LED, you probably heard of that. They're all over your house probably. Light bulbs used to be incandescent lights, and now they've changed a lot to LED. It's more efficient. So what does that mean? It means light emitting and diode. Okay, so diode, that's the word here. This little triangle with the line means diode. Okay, it means that electricity can only go one way. That's how I like to explain it. We'll probably go deeper into circuits and stuff in a future video, but I do want to say that for electronics to work, you need a flow of electricity. And the flow of electricity is like, I just think of like a network of streets. Now some streets are two-way, so without allow electricity to go two ways, but some streets are one way, and it only allows electricity to flow one way. So LEDs, which is a special type of diode, a light emitting diode, is a one-way street for electricity. Just some extra information for you. All right, so we have a diode, or a light emitting diode on the board, which is that blue light, which we'll play with in a second. All right, which is automatically connected. It's already connected on the board, on this blue board, to D4. Okay, like that. And then this needs to be connected to this black triangle, which is a symbol for ground, which is a symbol for GND. Okay, I won't get too far into that today, I think. But there needs to be a ground for every circuit. So if you want your electrical circuit to work, you need to connect somewhere to ground. One way to think of it is like when you're walking around, you need a ground to stand on, right? So it kind of makes sense. You need a ground. You need a ground to walk on. Circuits need a ground to connect to as well. Okay, again, we'll go deeper in the future about that. So we're connected. Another note here, we have a connection one side. This minus is connected to ground. The plus side, which I drew here, is connected to D4, and it's actually, there's a baby resistor in there. What does a resistor do? A resistor resists or slows down electricity. Okay, the way you think about it is that if that little LED has too much electricity going through it, it's gonna pop. It's going to get damaged, so you put a resistor to protect it. Okay, so that's already set up for you on the board, so you don't have to connect anything in order to get a light to turn on. Now in the future, maybe not in this video, but later, what if you want to connect also another light? Let's say, I'm going to get rid of this question mark here. Let's say you want to connect another light to here externally, and we do have a light in the kit there. You can also do that. So you would then connect another light, then have our GND, or black triangle, because all of our circuits need GNDs, right? And then we could also add an external resistor, like so. Okay, now we're not going to do that today, but that is one way we could have two lights turning on. You could have the onboard, the blue LED, and also an extra LED turning on and off at the same time. Okay, so D4 is set up with that onboard LED. Let me erase this so it doesn't confuse us. And it can be set as an input or an output, but since D4 is already connected to an LED, what do we need to set it as? It needs to be set as an output, because an LED is sending light out, right? We're not connecting a sensor or anything to it. All right, so all that to say, now let's look at the code, and the code will start making a little bit more sense, okay? All right, boom. All right, so let's go to the setup. So again, the setup function is part of the code that runs on the very first time that it turns on. It sets it up. It runs once and then it never runs again. All right, so that's where we want to put the stuff that is really important for our code or our program to do, but only one time in the very beginning. So you see this pin mode command? You see pin mode? Pin mode sets up the pin. Okay, the thing that we want to, the thing that's going to do stuff on our computer board can either be an input or output. And look, there you see words, output, 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 output. This echo one is an input. That's interesting. So echo might be for a sensor. I don't have a sensor connected to my race or my wheeler right now, but we're gonna have one later, and maybe I put some code in there so that our sensor will work when we plug it in. Maybe, but we're not doing that in this video. We're gonna look at outputs, right? Now let's look LED pin. Now I don't see D4 though, right? So if we look here, remember D4 is the one that's connected to the light. So what's going on here? Why do I see LED pin? Well, this all capital LED pin here, it's actually what we call a macro. And look, if you look up at the code, you see define, hashtag define LED pin, same thing that I see here, and then D4. Okay, so the macro is just another way to, I just want to relabel it. Instead of putting D4 here, I could also just put D4 here. Okay, but you know, it doesn't tell me as much as LED pin. Okay, just a relabeling. And by the way, what is D4? If you look at here, D4 is also, this is called a variable here. D4 is actually 2. Okay, what's 2? Well, we don't need to worry about that. You know, sometimes I'm going to say that we don't need to worry about that. But the real story here is that this inside the board, the D4 label gets converted into something else. And you see this silver chip right here where my finger is. Okay, that's the board that's actually being programmed. And then so somehow when you're programming the D4, inside that silver chips, it needs to be translated into number 2. Okay, but we don't need to worry about that. So that's why I put these variable assignments here for you. So just don't change it, don't touch it. All you have to worry about are these macro definitions here. All right. So we set LED pin and we set it as an output, right? Because it's sending light out. And then let's go down to the area that controls our commands here. Handle text. But I want to go to these control panel commands where we can use our app to talk to it. Okay, so last video we had 0 do this and 1 do move it backward, 2 would move it forward, and moving so forth. Okay, yes, we wrote this one. Remember, you press the 7 number and then it goes forward, stop, backward, stop. So let's make 8 turn on the light. So how do you turn on the light? It's digital write. Okay, that's the command. All right, and we're gonna put the pin. So it's LED pin. That's our macro for the LED pin, which is actually D4, right? And then comma high. High is gonna activate it, and then low is gonna deactivate it. Now sometimes it can be confusing. High might turn it on and low might turn it on. I'm not sure. We'll see. Let's find out together. All right, so I'm gonna compile this. Okay, it might take a second as I'm doing that. I'm gonna set up my phone here as well, because remember, we're going to use our phone to hook it up. All right. It's still compiling. Takes a little bit of time the first time. Okay, I'm plugging that in. All right, we're compiled. All right, remember the first time you compile is going to take a little bit of time, and then what happens is it's cached in there, so that the second time you compile it'll be much faster. All right, so let's Alright, so now we got that. We're compiled. Let's go ahead and upload. And then, so I'm on 6, connect. Alright, and it's doing this process. Uploading. Go. We're writing the new code. Okay. All right. Now, let's see. I wonder if the Wi-Fi comes on. I don't think it does. Yeah, I don't see it. So let's press this reset button. So let me change views here. So this reset button, boom. And then I think the Wi-Fi signal will show up. It's kind of good to learn things together. Oh, there, yeah. You see my Barnabas spot? Okay. Cool. And then now I gotta find my app. Here we go. All right, let's go to the control panel and do 8. Okay, you see that? 8 actually turned it off. Okay, so let's go back to our code here. So LED pin high actually turns it off. That's interesting, right? Now that's kind of counterintuitive, right? You would think high is like we're going up, it should turn on, and low turns it off. I won't get into it all right now, but like I said, sometimes this can get a little confusing. It's the way that the circuit's set up that will explain it, but we won't go all deep into that right now. So let's just be, smart here. So we have, if high is turning it off, then I think low would be turning it on, right? And then let's copy this and put it in this command 9 and put the high in there so that we have 2, right? 8 turns it off and 9 turns it, 8 will turn it on. I'm gonna put a comment here. On. These 2 slashes allow you to put a little note here so that it doesn't run. It's just a little note to yourself. Anything after those 2 slashes, okay? So this will be on and this will be off. Okay. Let's try again. So I'm going to upload. Or wait, we got to compile first. Let's see if it's faster this time. And I'll zoom in a little bit for you guys. Compiling. Still taking a little bit time. And so, but it was, I think, a little faster. So I bulk of the generating the code, the compiling portion, it did cache. All right, cool. All right, so then we compiled that, and then now we got upload. All right, and then it should work. Now, as that's uploading, let's talk about the loop. Okay, so we've covered the pins. The other thing I want to cover in this video is the while loop. All right, so let's talk about that actually right now as it's uploading, since kind of it takes a while, right? Okay, loop. What's a loop? What's a loop? A loop is something that goes in a circle, right? And so it's a very important thing in coding if you think about it. At a very, very basic level, why is code important? Why is it useful? Well, code is what runs on the brain of a robot. And we have a robot here, right? It's a car robot. And let's talk about that. Why are robots helpful? Well, robots can help us do tasks so that humans don't need to do it. And when robots first started, they were doing simple tasks. Right now, there's artificial intelligence and things like that, so that the robots are a lot more complicated. They can do all sorts of things, right? But in the very beginning, robots were very simple. And even now, there's still this element of like doing simple tasks over and over again is super helpful. For example, if you do some assembly in the factory, you need to go like this. Take this pen and then put it over there. Take another one, put it over there. Take it down, put it over there. You could create a robot to do that. And so the reason I'm saying all this is like, because a lot of times you're doing something over and over again. So then what you see is like it's going in a loop. It's repeating over and over again. And so obviously, in order to get a robot to do that, you need to put something in its brain, which is the computer, something in its brain to make it do something over and over again. Now, the thing you put into the brain of a robot is code, right? So our code that tells it to do over and over again needs a loop. All right, all that to say, loops are important. All right, so we got a loop. Now, there are many different types of loops. The one we're going to talk about is the while loop. Okay, and this is the way it works. While question mark, curly brace, curly brace, or I don't like that. I'm not gonna. I could say code there, but I'm gonna say tasks. Okay, what does this mean? This is C text coding for the while loop. So while question mark, the question mark is where you put your question. So while something is true, so this something is the question, then do the tasks. So inside where it says tasks, inside these pair of curly braces here, that's the stuff you want to do over and over again. So the tasks in this case would be pencil up, pencil down, pencil up, go over here, pencil down, pencil up, go over here, pencil down. So that would be your task. Now the question would be the while. So while you'll see while 1 equals 1, that's why am I saying that? That's called a forever loop, because does 1 equal to 1? Yes. Does 1 ever not equal to 1? No. So if you want this thing to go forever, you could say while does 1 equal 1? Then yeah, then it'll just go forever, right? But if you want to do something else, like this is not kind of realistic in code, or at least this situation, but you could say while and our question would be while the sun is out, do your tasks, right? So but now all of a sudden it's a little bit interesting, right? Because the sun's not always out. So it would be, our code is tell it to keep going, but then once the sun went down, it would be like, is the sun up? It's not. And then it would just stop. It would jump out of the while loop and then just stop. Okay? All right, so now let's go back and look, our code's uploaded. Of course, we were talking for a while, but if we remember, we wanted to, I know we're gonna kind of jump around a little bit. I think you can handle this. All right, we're talking about a while loop. We'll get back to that. Let's first see if the control panel thing works. So we want to do 8 should be turn it on and 9 should be turn it off. Okay, let's first reset, press our button so that we get the Wi-Fi to show up. Okay, Wi-Fi showed up. I'm gonna change the screen here. Wi-Fi shows up. Okay, now it should work here. Okay, so what was it? 8. Just turned it off. And wait a second, is this working? I'm not connected. Sorry, 1 second. Okay. Okay, I have to go to the home screen and make sure that this is connected. Okay, so you might run into that. If it's not connected, go to the home screen. Now let's go to the control panel. 8 and 9. 8 and 9. You know, I don't know what happened here. Did I think I'm crazy. Okay, 8. Okay, yeah, 8 turns it on. Sorry, I got confused again. Okay, 8 turns it on. 9 turns it off. 8 turns it on. I got confused just a second. So yeah, our code works. 8 turns it on, and 9 turns it off. Okay, so that's working. Let's now look at the while loop thing. Okay, let's do, what if I want it to blink off and on? Let's put it, and let's make a forever loop. Okay, so I'm gonna say, or maybe not, I don't know, let's figure it out together. While something, right? Remember these parentheses inside here, we put our question, but let's go ahead and just put our curly brace. We're gonna do this task. Our task will be to make it blink low. That will turn it on, and then this will turn it off. It's very confusing, so I'm going to put my little comment here so I don't forget. Now we need to put a delay in here. I'm going to say 500 milliseconds, which is half a second. Okay, I need to put delay because the commands, they process really fast. So if I want to just go in a loop and it's just low high low high low high, it will be turning blinking the light, but I won't be able to see it because it's going to be turning on and off so fast. It's like flickering the lights on your, you know, like in this room, super fast. You actually won't be able to see it. Your human eye won't be able to catch it. So we need to slow it down. I'm going to put 500. Okay, so this will say I'm going to keep it on for 500 for half a second. Then I'm going to turn it off and keep it off for half a second. A lot of times people forget the second one, and it's not going to quite work. All right, now what's my question? So while what is true? While the sun is out, well, I can't really write that in this code because I don't have a light sensor. So I'm just going to say while 1 equal 1. Now why is it not just a 1 equal? Well, in C code, a single equal sign means that you're trying to make a statement. You're setting 1 equal to 1, which, you know, doesn't really make sense, but you could do that, but that's not what we're doing. We're asking a question. We don't want to say 1 equals 1. We're going to say is 1 equal to 1, so that you need a second. All right, so that's going to be true. So that's always gonna be true, and then this will just keep blinking forever and loop and loop and loop. And actually what's gonna happen, your robot's gonna be stuck. You won't be able to let it do anything because other than blink, because it's not gonna be responding to the messages anymore either, because you need to jump out of this function in order to process new commands. Okay, if you get stuck in this infinite, this is called infinite while loop or forever loop, it's just gonna be stuck there blinking and no longer responding. It's just gonna be like if you have a thought in your brain and that's all you think about, and you're just daydreaming about that, you're not able to do anything. You need to jump out of it, snap out of it, right? And in order to do other stuff. So I'm sure this is gonna work. But I don't want to leave my robot in an infinite loop, right? Otherwise, because then it's just stuck. So let's ask another question. Instead of 1 equal 1, let's ask a question where that it only loops a certain amount of times. All right. I didn't know that I didn't think I was gonna do this, but I'm gonna introduce another thing, variable. Okay, let's do this. Int counter. Okay, we're gonna create a variable called counter. What is a variable? A variable is like a box. I like to say it's like a box. Better like this. Like I have a cup here. This is my variable. Now, what's in the box or what's in the variable can be different things. Right now, it's coffee. But if I emptied the coffee, you can see kind of a little bit. I don't want to spill it. It's a little coffee in there. But if I empty the coffee, it'd be no coffee. But if it's coffee in there, then there is coffee. So the counter is like the cup, right? But the value or what's inside of it can be different. Now, what's in our counter? It's not coffee. It's going to be numbers. All right. It's an integer number. So it could be negative or positive. All right. But we're going to do positive numbers. I'm going to say our counter value. I'm going to set it to 0. And we're going one equal sign, not 2, right? Because we're not asking a question. We're saying counter equals 0. We're not saying is counter equals 0, right? Counter equals 0. And then we're going to say this. Instead of 1 equals 1, we're going to say counter less than 5. And then inside here, counter equals counter plus 1. Okay, so what's going on here? We're saying while counter is less than 5. So it starts at 0, right? So if it's 0, is 0 less than 5? Yeah. Then it's going to blink. And then look, at the end of our task, we added counter equals counter plus 1. If we read that, if it starts at 0, first counter 0 is going to add 0 to 1, then counter is going to be 1. So we're adding 1 to counter each time we do our task. All right, and then it's going to keep looping. But each time it loops, counter is going to increase by 1. So start at 0. Then it'll go to 1, and then counter will be 2, and then counter will be 3, and then counter is 4. Is 4 less than 5? Yeah. It'll do it. And then once counter is equal to 5, it'll get back to here and say, is 5 less than 5? No. And then it'll stop. All right, so based on that, how many times will it blink? It's kind of confusing, so let's work it out. All right, so we have, it's going to start at 0. Okay, is 0 less than 5? Is it going to blink? Yes, that's 1 time. 1 is going to blink. 2 is less than 5, it's going to blink. 3 is less than 5, it's going to blink. 4 is less than 5, it's going to blink. 5, is 5 less than 5? No. It will not blink once it's equal to 5. So it's 5 times. I think. Let's try. All right. So let's try this. The star. So here's the star. Will make it blink 5 times. Let us try. Okay, and I'm gonna leave it at that. All right. So as this is compiling and uploading, let's talk about what you could do with this. All right. I'm pretty sure it should work. I don't know, sometimes my code doesn't work, and then that's just kind of a surprise learning opportunity where we can debug or fix it together, but I'm pretty sure this will work. So I would say some things you can try with this. Let's say if I said, when you press the star, I want it to blink 10 times. What would you do? Or 20 times. How would you change the code? Okay, that's one thing you can work on. Okay, let's upload now. Okay. What else could you do? We have a loop. What if you wanted to make it blink faster or slower? What would you change in the code to make it blink super fast, or have it blink super slow? And then something that is not so easy, but what if you wanted to make it blink while it's driving? How would you do that? I don't know. fun part is you can try. All right, so let's go back to our thing here. All right, I'm gonna reset. We're gonna reset so you're able to connect. All right, I'm gonna do my connection here. Feel like I would be good at this point, but still learning. Okay, I'm connected to my network. Okay, Wi-Fi is connected, and let's go to our, make sure you can see the light here, control panel. All right, 8 is on, 9 is off. 8 is on, 9 is off. So that works in star. Let's see. 1, 2, 3, 4, and 5. Sweet. It works. Awesome. Okay. So I'm going to leave it at that. And so some things that you can try is, yeah, make it blink a different number of times, 5, 10, 20. Make it blink fast. Make it blink so slow. And then, yeah, can you get the blink while it's moving? So you have code here. Like when you put 7, it's going to go forward and backwards. But could you also make it blink as it's doing that? How would that work? Okay. So give it a shot, and I will see you in the next video. Take care. Oh, also, any questions, you can comment or email at support@barnabasrobotics.com. See you later.